proton charge, the ratio of distance of closest approach of the proton to that of alpha particle will be. So we will solve this question. First of all, we'll see what will be the key concept used to solve this question. The key concept that will be used to solve this question will be at closest approach, all kinetic energy changes into potential energy. So KEI is equal to PE final, and KE final is equal to 0 at distance of closest approach. Kinetic energy becomes 0, and initially potential energy was 0. So from this is conservation of mechanical energy. So initially kinetic energy was half mv square, and at closest approach, if q is the charge of the particle and qn is the charge of nucleus, this is capital Q is the charge of nucleus and q is the charge on particles. So the potential energy is kqqq by r, where r is the distance of closest approach. Now we will see for proton, if charge is, so on proton charge is E, while on alpha particle charge is 2E, and they are having equal velocities. So V is same. So we will call V1 is equal to V and V2 is equal to also V, and the target nucleus is same. So Q1 is equal to Q, nucleus charge will also be same. Now we have to find the distance ratio of distance of closest approach. So we are taking R1 as distance of closest approach for proton and R2 as distance of closest approach for alpha particle. So we will have for proton, we will have half mass of proton is, if mass of proton is m, then mass of alpha particle is 4m. So this will be half into m into v squared is equal to kqe by r1. So from here we will have r1 is equal to kqe by 2kqe by mv square. This is r1. Similarly, for alpha particle, we will have half into 4m into v square, that is equal to kq into 2e by r2. So from here we will have r2 is equal to kqe by v square mv square. This is so r1 by r2, that will be equal to r1 by r2 will be equal to 2. So the correct option will be option B, 2. Hope you all understood it well. Best of luck.